Here's another Hess's Law challenge for us. They give us the overall equation down below. Notice that they have P4O10 on the left side of the overall equation with a coefficient of 1. Based on that alone, and the fact that we only see P4O10 in step 2 of the mechanism, let's flip around reaction 2. So we're going to flip reaction 2, but keep the coefficients the same. Okay. How about the fact that in the overall equation there's 6 PCl5 on the left side of the equation, and the only place we see PCl5 is in equation 3, and it's on the right side with a coefficient of 1. Based on that, we need to do two things. Let's flip and multiply by 6 all the coefficients in the third reaction. And then lastly, let's take a look at the 10Cl3PO that's in the overall equation on the right side. The only place we see Cl3PO in the mechanism is in step 4. It's on the correct side, but its coefficient is only 1. So let's take that last equation and multiply all coefficients by 10. We're trying to recreate the overall equation from the steps in the mechanism. In order to do that, we have to make sure that all of the other species that appear in the mechanism cross out. The only way to ensure that is to keep that first reaction as is. So don't touch that first reaction. After doing all these manipulations, let's rewrite each of the equations and see what can cross out. The value of delta H will change. It'll be flipped or multiplied just the same as the coefficients in the equations that we're treating. So the first equation was kept exactly as is. The second equation flipped around. So we'll rewrite it as written the other way. And the value of delta H, instead of being a negative 2976.3, is now positive. For the third equation, we flip and sextuple. That means the value of delta H is 6 times the magnitude as before, but with an opposite sign. So instead of a negative 84.2, it's a positive 505.2. Lastly, the fourth equation. Keep everything on the same side, but the coefficients are 10 times as high. Yikes. Now let's add these reactions together and see if we can indeed recreate the overall equation. If we can, then we did it right. So first thing I notice, 5 oxygen molecules on the right side in step 2 crosses out with 5 oxygen molecules on the left side in step 4. The P4 in step 1 and in step 2 crosses out. The 6 chlorine molecules in steps 1 and 3 cross out. And this last one's kind of interesting. In both steps 1 and 3, we have PCl3 molecules on the right side of the equation. We can add together their coefficients. 6 and 4, together that's 10. Those 10 PCl3 molecules on the right side of the equation just cancel out the 10 PCl3 molecules on the left side of the equation in step 4. After crossing all of that out, let's see what's left, what's not crossed out. Does the equation we produced match the overall equation? Indeed it does. That means we've done it correctly. The last step is to just add together these values of delta H exactly as they're now written, because they were manipulated from the original values of delta H. So we just need to add them together. The calculation's not hard. Pull out your calculator, and this one works out to be 610.1 kilojoules.